Hello, grade 8 students. This is day 11 of STP Mathematics 3A free math lesson series. Yesterday, if you can remember, we started the indices lesson, and I want to explain that I just gave you the introduction to the indices, but today I'm going to discuss the whole thing, that the concepts which you have learned in grade 6 and 7 and many more, the steps, right? So then straight away we will move to the whiteboard, and you can continue your note in your theory book. And I told you, if it is 2 to the power 3, what does that mean? Now you just look at this. If you have something like this, 2 to the power 3 multiplied by 2 to the power 2. What does this mean? 2 to the power 3 means 2 times 2 times 2, and you multiply it by 2 times 2, right? So then altogether, what do we have? 2 to the power 5, right? Okay. So can't we write this straight away, that if you have the same base value, 2 is the base value here, you have the same base value, and you have the multiplication. What we do, without writing this expanded version, we just add the indices like this, right? So then I write 2 to the power of 5. Okay, 2 times 2 times 2, then 2 times 2, then 2 to the power 5. Without writing this much, if you come across with the multiplication with the same base value, that should be the condition, children. To add the indices like this, you should have the same base value. If I do another example, let's say you have x to the power of 8 multiplied by x to the power of 3. What you can do, you write x, the base value, then you add the indices 8 and 3. Then my answer is x to the power of 11. Right? It can be anything, right? It can be anything. Let's say you have m to the power of uh, negative 2 times m to the power of 5. What you are supposed to do, you just add that, you write the base value and you add the indices like this. Either it is positive or negative, you don't want to worry. So then that becomes m to the power of 3. Negative 2, positive 5. It is positive 3, no? So then you just write it like this. Okay. And then if you have the division the same way, you just see you have 2 to the power of 5 divided by 2 to the power of 2. How I'm going to write this? 2 to the power of 5, I write it like this, the expanded version, right? So then I have 2 to the power of 5. And that whole thing you divide by 2 to the power of 2. So then when I cancel this, what happened? It gives me 2 to the power of 3. Or the same thing I can do in another way. Here this is a division and the same base value. What you are supposed to do, we just subtract the indices, right? So then it is 2 to the power of, okay, 2 to the power of 3. 5 minus 2, it is 3. Right? The same way that you can do all these steps, the two condition. So it should be either multiplication or division, and they should have the same base value, right? Then let's say that the same example I'll take here, 5 x to the power of 8 divided by x to the power of 3. What you're supposed to do, you write x here, and inside the bracket you subtract this. So what will be the answer? X to the power of 5. And then the sixth one, what they had earlier, m negative 2, m to the power of negative 2 divided by m to the power of 5. Now what happened? What you are supposed to do? From negative 2, you want to subtract 5. Okay? So then you write m to the power of negative 7, right? So then I later explain you how you can write this m to the power of -7 as a positive index. But for the time being here, I just wanted to explain you either you have the positive index value or a negative index value. The only thing you want to do, if it is the same base value and a division, you want to subtract. By any chance, I'll show you an example, the seventh one. By any chance, let's say you had something like this, m to the power -2 divided by m to the power -5. Now what you should do? You write the same m here, and then you write that you want to deduct -5 from -2. You deduct what? -5. Okay. In that case, you use the box bracket like this. Hope it is clear. Right? So then if it is at the negative, both are negative, that you write that negative sign as it is. And the subtraction, that's the math operation. So then you know this negative and negative becomes positive. So then you write m to the power negative and +3, so +5, +5, and you conclude the answer m to the power of, right, m to the power of 3. Hope it is clear. If it is the division, we want to do the subtraction. Either you are subtracting a positive value or a negative value, that's something else. If you have the division and the same base value, you want to subtract the indices. You want to get the difference of the indices. And if you are dealing with the negative signs like this, better to use the small brackets and the box bracket. So then it gives you a clear path to do the simplification. Okay, like this, right? So then I want to explain you something else. If you have 2 to the power of 0, what is the answer, children? 1. 3 to the power of 0, what is the answer? 1. 5 to the power of 0, what is the answer? 1. X to the power of 0, the answer 1. Right? M to the power of 0, the answer 1. Let's say we have 2/5 to the power of 0. Still the answer is 1. Let's say you have 0.8 to the power of 0. Still the answer is 1. You have x/2 to the power of 0. The answer is 1. What does this mean, children? Whatever the base value, maybe the base value is a whole number, maybe the base value is a letter or a fraction or a decimal or an algebraic fraction. Whatever it is, if the index is 0, always the answer will be equal to 1. Right? So you just look at the index value. If the index value is 0, whatever it is, the answer will be equal to 1. Index is 0, the answer is equal to 1. Now we'll see the other way around, right? So this is one theory. We have done these things in grade 7, but I'm just revising. 2 to the power of 0, 3 to the power of 0, anything, any base value. Index is 0, the answer is 1. Let's say you have something like this, 2 to the power of 1, the answer is 2. 3 to the power of 1, the answer is 3. 5 to the power of 1, the answer is 5. X to the power of 1, answer is x. Right? M to the power of 1, answer is m. 2/5 to the power of 1, the answer is 2/5. See that the same thing I am writing, 0.8 to the power of 1, the answer is 0.8. Right? X/2 to the power of 1, the answer is x/2. Right? So what does this mean here? Whatever the base value, if the index is 1, the answer is equal to the base value. I repeat, whatever the base value, if the index is 1, the answer is equal to the base value. Answer is equal to the base value, right? X to the power 1, it is x is the base and answer also x. So then m to the power 1, m is the base. The answer is also m. So whatever it is, the same thing, right? We are done. Then I'm moving to another part. You just see, children, if I give you 3 to the power 2, you know what to do. 3 times 3 equal to 9. But if I give you 3 to the power of negative 2, what you are supposed to do now? If it is 3 to the power 2, we know we want to multiply the base value 3 two times. That's the indication we get from the index. Because it is 2. You want to multiply the base value 3 two times. But here it is negative 2. We can't do anything. So we want to convert this negative index into a positive index. How we are going to do that? We get the reciprocal. How? The 3 to the power negative 2 over 1. And I get the reciprocal 1 over 3 to the power of positive 2. When you get that negative 2 down, so simply when you get its reciprocal, so that negative 2 index become positive 2. Now I know what to do. 1 divided by 3 times 3 equal to 1 over 9. Right? The same way, let's say you have 6 to the power of negative 3. How I'm going to write? 6 to the power of negative 3 over 1. And I write 1 over 6 to the power of 3. Positive now. So then I have 6 times 6 times 6. Right? So then I know I want to multiply 6 by 6 3 times, not 6 by 3. 6 3 times. It gives me 1 over 216. I'm not sure that whether I said that the 3 2 times. That means not 3 times 2. 3 you want to multiply 2 times, right? So then here 6 you want to multiply 3 times. Okay. So let's say that you know that if you come across with a negative index, you want to make it positive. How we are going to make it positive? You get the reciprocal. Now I'll give you another example. Now you just see if you have something like this. 1 over 2 to the power 2. What does this mean? You want to multiply 1 over 2 fraction 2 times. So that gives me the answer 1 over 4. But if it is, let's say, 1 over 2 to the power negative 2, what does this mean? That this is negative, that I can't do anything. I want to get the reciprocal of the base value. No? So what is the reciprocal? Here it is 2 over 1. Now this negative 2 become positive 2. What does this mean now? 2 over 1 multiplied by 2 over 1 equal to 4 over 1 equal to 4. Right? Let's say we have something like this, 2 over 5. Now you just see what's the pattern. You can identify a pattern here, right? So then here 2 over 5 multiplied by 2 over 5. The answer is 4 over 25. Okay. But if you have something like this, let's say 2 over 5 to the power negative 2. First of all, you want to remove this negative sign. No? So then we get the reciprocal that becomes 5 over 2. Now it is not negative 2, positive 2. So then we write 5 over 2 multiplied by 5 over 2. So then is equal to 25 over 4. If need, you can simplify this and write like this. Hope it is clear. Now we will just see, children, what has happened here. 1 over 4, 4. 4 over 25, 25 over 4. Can you see? So then when you get the reciprocal, so as you had the negative index, you had to get the reciprocal. So then you get the answer also, it's reciprocal, right? I'll do one more question for your knowledge. Let's say you have 3 over 4 to the power 3. What does this mean? 3 over 4, 3 over 4, and 3 over 4. What is the answer? So, 3 over 4. Answer is 27 over 64. Right? The same way, if you have 3 over 4 to the power negative 3, we have 4 over 3, we get the reciprocal, so the negative 3 becomes positive 3. So then we write 4 over 3, and we get 4 over 3, and 4 over 3 like this. So then that becomes 64 over 27, right? So when you divide 64 by 27, it gives me 2 wholes, right? So then the 2 wholes, in the sense it is 54, and when you deduct it from 64, it is 10 over 27. Hope it is clear for all of you, right? So we'll go to the textbook and see what you have. Yeah, I think you don't need to do everything. It's enough to do this exercise 1J as the homework because it covers everything. It covers everything I explain you. Do all these 20 questions in exercise 1J. Okay, children, we'll meet again next day. Until then, stay safe. Go through the theory that whatever the note I gave you, right? So complete it, pause the video and write down all these examples. Complete the note, go to the textbook and do exercise 1J. See you then. Bye.